finals coming up, I assume?
No finals actually, but I do have a quiz.
Okay.
We're on a trimester system, so
Oh, okay.
it's only like halfway through for us, but luckily.
Uh-huh.
But we're doing linear programming.
Okay.
And I kind of, it's weird because I get it, like, for some of them I get it really easily.
Okay.
For others, it's a little bit trickier, but it's really just, for me, I've noticed it's just figuring out, I guess, you know, like what to graph and then what to write down. It's like kind of picking apart the question, I guess.
So when you end up graphing all of your conditions, then to evaluate, you go to the vertexes on your graph. You go there, 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 and there, and there. And you evaluate the objective function at each of those points, and whatever gives you the largest number, that's the one you do.
Right. And pretty much all the ones that we've been doing have two lines.
Okay.
So it's where they intersect.
Right. And that's the tricky part, is you have to figure out where they intersect. So you might have a line like that, and another line like this, and this is your area. And so you're going to check this point, you're going to check that point, and you're going to check that point. And the only one that's tough is that, because you have to solve the two equations to figure out what that point is.
Mm-hmm.
Okay, do you have a real one let's do? I mean, an actual problem?
Yeah, I do.
Okay.
Let's see. Okay. Do you just want me to read it out, or?
Yeah, let's read it out, and I'll try to start writing the conditions.
Okay. An aquarium is 2,000 cubic inches.
Okay.
Finn wants to populate the aquarium with neon tetras and catfish. I just said NT. Okay. It is recommended that each neon tetra be allowed 50 cubic inches of space, and each catfish be allowed 200.
Okay.
Finn would like at least one catfish for every 4 neon tetras.
Okay.
And then what is the maximum number of each type of fish that Finn can put in his aquarium?
Okay. So, if I want to lay out some inequalities, I've got NT. Oh, hold on a second. Let's see. Let me think about this for a moment.
The only thing that's throwing me off on this one is the one catfish for every 4. I guess I'm kind of like confused as to, because I know that's kind of a big part of the.
Yeah, well, that just gives me the equation NT equals 4 CF.
Okay. Then that's the maximum equation?
No, let me think about that for a second. For the objective function. The objective function is going to be 50 times NT is the amount of space it needs, plus 200 times CF has to be less than or equal to 2,000. That's one of our constraints.
Yeah. Yeah, I got that far.
And NT has to equal 4CF. That's another. And our objective function. What's the question? He wants to maximize what?
He wants to maximize the number of each type of fish.
For some reason, I'm having a hard time coming up with an objective function for here.
Yeah, this one was kind of confusing.
The objective function would be I'm not sure.
Is the objective the maximum? We said, or she makes us write out as max.
Yeah,
Maximum.
That's the function
Okay.
you're trying to maximize. Question
Yeah.
is, what is it here? She's trying to put as many fish as she can into this 2,000-foot aquarium.
Mm-hmm.
All right, I think we can figure this out. Let's see. So the amount of fish we let that equal x, and this equal y. Then we have 50x plus 200y is less than 2,000. Let's graph this first before we think the objective function might come to us if we look at a graph of this. So if I graph the 50x plus 200y is less than or equal to 2,000, the x-intercept is what on that?
40.
And the y-intercept?
10.
And it's this part of it. Okay, and then if we graph this, x equal 4y, it means y is equal to 1/4 x, so that would have a slope of a flat slope, like that, and we go through 0, 0. So it would appear that the area we're investigating is that area there. So we need that.
Wait, the second one is... Wait, how did you get that second line?
X equal 4y. X was the number of nettle fish or whatever.
Yeah.
And he wants one catfish for every 4 of those, so y would equal 4x, not the other way around, yeah. It's y equal 4x, right?
Mm-hmm.
Yeah. Now hold on a second.
Yeah, for one catfish, 4 little fish.
Yeah, and x is the little fish. Okay. So
wait, but then I don't get how you do
I got that backwards. I got that backwards. In other words, if x is 1, we're going to have 4 big fish. And we don't want that. It is 1/4. In other words, if we have, for every 4 NT fishes, we're going to have 1 kettlefish. And that makes sense because the NT fishes take up only 1/4 of the space. So you would want to have 4 of these for every 1 of those. So y equals, so if, So if I had 4 nettlefish, I would have 1 catfish. This is correct.
Correct.
So I think I was right there.
But no, but what I mean is I don't get the line. Like,
That's
how do you know
just
the
the
line?
slope. In other words, that's if you use y equal mx plus b.
Yeah.
That graph
Oh, okay.
goes through the origin, and it has a slope of 1/4.
Okay.
Okay? Now, so we know the points we want to consider. Let's figure out that intersection point. How do we do that?
We solve the 2 equations.
Well, let's do it by substitution. In other words, I'm going to substitute 1/4 x for y. So I got 50x plus 50x. In other words, if I substitute 1/4 x for y, then this turns into 50x. So I got 100x less than or equal to 2000x less than or equal to 20. So the x coordinate on that is 20, and the y coordinate would be 5. See how I got that?
Yeah, how'd you get the 5 though? Just by looking at
Just
it?
by plugging in 20 for x,
Oh, yeah, okay, yeah.
and therefore y would be 5. So I know the coordinates on that point. I know the coordinates on these 2 points. So my objective function read the last sentence. He wants to put as many fish as he can.
It's what is the maximum number of each type of fish that Finn can put in his aquarium. So he can, so I think that this is it. I don't even think it needs a maximum because it means that he can put 20 NT fish and 5 catfish. Because it's not asking
20 of those would take 1,000, and 5 of those would take 1,000. So you're right, we do have the answer. What I don't get is, where's the objective function? Maybe there isn't one for this.
Yeah, I don't think there is.
Maybe not all linear programming problems are with an objective function. Notice he could also put 40 of the little ones in there. Oh no, but then he wouldn't have the 1-to-4 relationship. Okay. All right, now we've done this. There isn't an objective function. Okay, do you have another one?
Yeah. Okay, this one's a little bit longer.
Okay.
So, your doctor asks you to eat a diet that includes at least 140 milligrams of vitamin A,
okay,
and at least 145 milligrams of vitamin B.
okay.
These requirements can be obtained from 2 types of food. Type X contains 10 milligrams of vitamin A and 20 milligrams of vitamin B.
Okay.
Type Y contains 30 milligrams of vitamin A and 15 of vitamin B. Oh, and each of those are per pound, sorry. 15 milligrams per pound and 30 milligrams per pound.
Okay.
I don't know if that makes a difference. Type X costs Type X costs $12 per pound, and Type Y costs $8 per pound.
Okay.
How many pounds of each type of food should you buy to satisfy the requirements at the minimum cost?
Okay, so it sounds like we have an objective function now. The cost. We're going to minimize the cost. Okay, what's the cost going to be?
Okay, the cost.
It would be $12 times X
Yeah, 12 times X plus,
plus
8
8
times Y.
times Y. So there's our objective function. So
Okay.
now, let's see. Let's go down and try to graph this thing. Vitamin A needs to be greater than 140. Hold on a moment. Let's see. So X contains 10 of vitamin A and 20 of vitamin B. So the amount of vitamin A you get is going to be 10 times X plus 30 times Y. That'll equal the amount of vitamin A, right?
Mm-hmm.
In other words, if you bought 2 pounds of X, you'd get 20 milligrams of A, and if you bought 3 pounds of Y, you'd pick up another 90 milligrams of A.
Mm-hmm.
So these are our 3 constraints, that, and that. Okay, that's relatively easy to graph. If I graph this one down here, this has to be greater than or equal to 140. And vitamin B is 20X plus 15Y has to be greater than or equal to 145. So these are the 2 constraints. You see how I got those?
Yeah.
In other words, the doctor said you need more than 140 milligrams of vitamin A. Well, this is how much vitamin A you get. 10 times X plus 30 times Y, so that has to be greater than 140. And then the vitamin B you get is 20 times X plus 15 times Y, and that has to be greater than 145. So let me erase these 2, because I've already got that information down here. Now let's graph those 2 equations. X and Y coordinates is the easiest way to graph these. What's the X coordinate?
14.
And the Y coordinate?
4.6.
And the second one, the X coordinate?
Is 7.25. And then 9.6.
Hold on. So if I connect those, we need that intersection point. What's the best way to solve these 2 equations? Find that intersection point.
Probably substitution again.
I like elimination because it's so set up for elimination at this point. Notice that I got my y's and x's on the left side. I got numbers on the other. If I multiply the bottom by 2 or the top by 2, I'll be able to eliminate a variable. Let's multiply the top by minus 2. So it becomes minus 20 minus 60 minus 280. Now add the two equations.
Multiply the top by 2?
Minus 2. By minus 2. The reason I did that is because most people prefer adding equations to eliminate a variable rather than subtracting equations. So when I multiplied it by minus 2, it changed that to minus 20x, and now I'm going to be able to add these equations. The x will go away. I got minus 60y plus 15, so that's minus 45y equals minus 135. Y equals 3. So if y equals 3, x equals 5 by just plugging back into this equation. If I plug y equal 3, I get 15 times y is 45. I got another 100, so x has to equal 5. So this point is 5, 3. Now we have all of our points to plug into the cost function, and whichever one gives us the minimum amount, that's our answer. So let's try 5, 3 for starters. What is the cost of, I'll write it up here. So the cost at that point would be equal to what?
Let's see. $84.
Okay. How about the cost right there? At this, in other words, we need to examine each of these points, that point, and that point, to determine what might be the lowest cost.
Okay.
So what's 7.25 times 12? More than 84.
Yeah. It's 1,537.
No, just 12 times 7.25, this vertex, the x-coordinate.
Oh, sorry, yeah. 12 times 87.
Yeah. Okay, and then examine this point here. In other words, 4.6 times 8, because there's 0 x's and 8 y's when we're at that point.
Yeah, 36.8.
That would appear to be the minimum cost, $36.8. Which means what? It means that we want no x's and 8 y's. Now let's just see if that meets our criterion. In other words, we're not going to buy any of the x's. We're going to buy 8 containers of y. Or, let's see, we're going to buy, 8 pounds of y. And that 8 pounds of y is going to give us 240 milligrams of A, which doesn't meet our requirement, and 120 milligrams of B, which doesn't meet our requirement. So that's not the answer. The point's got to be this point here.
I think it's the one in the middle because
Yeah.
it's not it's
right.
the more expensive one, but it's the only one that meets the
It's
requirement.
the only one that meets the requirements. If you get 5 pounds of X and 3 pounds of Y, you'll get 50A there. You'll get 90A here. That's 140, which meets your minimum. And you will get 100 milligrams of B and 45 milligrams of B from that, which is 145, which meets your requirement also. So that middle point's the only one that meets your total vitamin requirements.
Yeah.
So, I don't know what I was thinking in examining this point here. This point down here would mean you would have 7 of X and no Y. So that wouldn't satisfy it either. The only point that satisfies your requirements is that intersection point.
Right.
Okay.
And one thing I've noticed, I mean, I don't know if this is just the way she did it, but all the problems she gave us, it was always the intersection point, which is the answer.
Yeah.
Is that
It's a little different. The linear programming problems I have in my book, usually you have to examine all the vertices, and it's not always the intersection point that produces a max or a min.
I mean, she makes us examine them all, but they just always come out as the intersection, which was weird. But
what I'm puzzled about is these other vertices don't satisfy the requirements. Usually all the vertices satisfy all the requirements. But anyway, I'm sure we came up with the right answer. 5 of X and 3 of Y.
Yeah.
All right. Those were 2 hard problems there.
Yeah, I think I get it. It's really just kind of like picking apart the problem, you know?
Yeah, setting it up. These linear programming problems are hard, no question about it. They're really hard. In fact, I've always objected to the fact that they start Algebra 2 students out with linear programming. That's starting out geometry with proofs. You might as well try to teach somebody to ski by putting them on the expert slope. And I don't like that. I think math is best learned easy to hard. So, but anyway, hopefully this helped you a little bit.
Oh yeah, definitely.
Setting up this part right here is really the tough part.
Yeah. Yeah, once you have the 2, you can at least get a point.
Yeah. Although
she grades them with like sections. So if you get like the graph, that's 1 point, you know.
Okay.
So.
All right. Well, Thomas, I hate to have to run, but I got an 8:30 that I got to do also.
No problem.
Okay. I will.
All right. Well, thanks. Good luck with your car.
Thanks. Good luck on your quiz.
All right. Thanks.
Talk to you later. Bye-bye.
Bye.